Hello, this is Mrs. McConnell, and we're starting lesson 12.3 talking about properties of acids and bases. And from this first picture on this slide, we can see lots of different things that are constituted as acids and bases. On this side of the picture, most of these substances are bases. Notice that several of these are actually used in cleaning. You don't really ingest a whole lot of bases. Sometimes medications like milk of magnesia can help with upset stomachs because you have a high acidity in your stomach. Notice that even blood falls on the bases side of the things. Your blood is actually slightly basic, even though it is pretty close to neutral like water. Okay, on this side, you will see lots of things that you do eat. These are mostly all acids. Milk, again, is just a little bit acidic, almost neutral. And so we've got quite a few things like fruits, candy, those kinds of stuff that you eat that are bases. Now, first thing we want to do is be able to recognize acids and bases based on their formulas. And hopefully you're seeing a pattern with all of these acids. They all start with hydrogen. I'm going to put H plus here because this is a hydrogen ion, and an acid is made up of a hydrogen atom or two and an anion. Notice that chlorine, that's an anion. Nitrate, cyanide, acetate, we've got citric acid. Citrate is a 3- charge. That's why we need to have 3 positive hydrogens to balance out that anion. So sometimes you'll see more than one H at the beginning. It's still an acid. Okay. What do most, not all, but most of these bases have in common? They all end with hydroxide, OH minus. Okay, that is hydroxide. Now, we see 2 of these that don't follow that pattern. Sometimes they may end with an amine group. That is a nitrogen group. Nitrogen with some number of hydrogens. Okay, like this one is methylamine, and this is ammonia. This is just one you should know. It is a base, but it does not contain an OH group or really an amine group, but it does have that nitrogen and hydrogen. You will only be asked to write names and formulas for hydroxides, but you should be able to recognize bases if they have an amine group or that NH group. Okay. Some other properties consist of their taste. Acids typically taste sour or tangy. Think about candies that are sour. Any type of fruit has lots of different acids. Juices, okay? Those sorts of things contain lots of acids. Just look on the back of a can of pop. There are all sorts of things listed. Many include acids. Okay? Bases taste very different. Bases typically have a very bitter taste. If you've ever had soap in your mouth for some reason, it tastes kind of gross. It tastes bitter. Same with things like coffee tend to taste kind of bitter because they have a lot of caffeine, and caffeine is a base. Okay? Some people like the bitter taste, others don't. They feel different. If you touch an acid or a base, they're going to have a distinct feel to them. Now, you shouldn't put your hands in chemicals in the lab because we have very concentrated acids and bases, but in regular life, when you touch an acid, it sometimes feels sticky or oily. Oleic acid is the main component of olive oil. It feels kind of greasy. Okay? Any type of oil feels kind of greasy. That's a different kind of slippery feeling from soap. Soap has a kind of bubbly, slippery feeling. It's very slick, feels sudsy. Okay? Bases tend to feel that way because there are a lot of bases in things like soap. Soap is a base. Any type of cleaner tends to be a base. So that's why it has that kind of squeaky, clean, slippery feeling. They react differently with metals. So most metals, when you put them in acid, are going to create hydrogen gas as well as some form of salt. Now, corrosion is a type of salt. It's just not the salt you're typically used to seeing, like sodium chloride that will dissolve in water. But these are extremely, oops, it got stuck. Sorry, technical difficulties. Highly reactive. For instance, battery acid, if you've ever tried opening a remote because it wasn't working and then you saw this weird coloring in there and this crusty stuff, it's probably because some of the acid inside of the battery leaked out and it started reacting with maybe the metal spring in your remote or the metal of the battery itself. Okay, this is actually a picture of the acid cabinet here at North Star, and it has corroded the lock. You can see different types of metal must have been in here because we've got kind of a reddish black salt or rust formed here as opposed to this kind of white green powdery stuff that formed on the other part of the lock. Okay, very reactive with metals. Bases, on the other hand, do not react at all. Okay, not reactive. Now, if you remember from the little lab that we did, the little mini lab, then we tested acids and bases on some different types of indicator paper. Litmus paper is a type of paper that can indicate whether or not you have an acid or base. It won't tell you what kind of acid or base you have or what the pH is. It'll just help you know if you do have one. When you put the red litmus paper in acid and even the blue litmus paper in acid, you noticed that it either stayed red or turned red. So the red litmus paper stays red, the blue litmus paper turns red. Okay. On the other side of things, if you put red litmus paper in a base, it turns blue, and if you put blue litmus paper in a base, it stays blue. Okay. The other type of paper we used in our little mini lab was this pH paper, and pH paper is great because you can get sort of a read on what the pH number is because these coordinate with specific numbers. So for instance, you put this little yellow strip of paper into an acid and it can turn red or orange, whereas if you put it in a base, it turns green to blue. Typically, red will correspond with a pH of something like 1 or 2. Orange is about 3 or 4. Now, if it stayed yellow, you have a pH of 7. This is neutral. Whereas a base, this might be 9 or 10. This might be 11 or 12, something like that. Okay, there's variable numbers associated with these colors. It kind of depends on what type of pH paper you have. But in general, bases have a pH that is greater than 7. Acids have a pH that is less than 7. Okay. If you have 7, it's neutral. I'm going to play you a little video of me doing this demo for you, and then you can answer these questions here on your own, and hopefully I've got the volume up loud enough. Here we go.
What we have in here is something called universal indicator. It's this kind of greenish yellow color, and on this first side, we are going to drop in a couple drops of 1 molar hydrochloric acid. See that it turns kind of a pinkish red color, and what we're going to do is cork it and then flip. You can kind of see that color spread a little bit through the column. On the other side, we are going to drop in a couple drops of sodium hydroxide. And as you can see there, it's actually turning the purple spread, and we have a really awesome rainbow. What universal indicator does is it's an acid-base indicator, so it turns red to possibly orangish color when it's an acid that's added, and then it turns purple to blues to even slightly green when you add a base. So what we can do, turn it again, and we're going to dump it in this beaker here. And you can kind of see that our solution here is sort of bluish color, means that there's a little bit more base than acid, and so we can add a couple drops of acid. And you can kind of see it change to a greenish color. Now think about acids turn it red if you put enough in there, so this is probably neutral with that green color. We could add a little bit more, and we get a yellow all the way to red. Then how would we turn it back to maybe purple? Well, hopefully you're thinking, add a base. There we've got green again, so it's probably about neutral. We kind of got a blue. Now you got a nice deep purple. This is the rainbow.
Don't want to start that over again. All right, so that's what we did in class, and we tried to get it back to neutral and did a pretty good job. What color was the universal indicator to start with? That was green. What happened when you added an acid? Well, I like to think red hot acids, so it turned red, and then it spread to kind of an orange color as you had less acid moving through that column. On the other side, when you added the base, sodium hydroxide, it turned purple. When we flipped it, again, some of the base spread through the column, and we ended up with a kind of blue color from there. Now in the middle you should have seen a kind of yellowish green color. Really we're back to the same color as the indicator was in the beginning. That means that it is neutral. There's an equal amount of acid and base at that point. Okay. I put a little bit too much base in that one side, and so when we poured them together it was purple or a little bit blue. If you put in the exact same amount of acid and base, when we poured it into the cup, it should have looked green or should have looked yellow. And that did work in class, but not in the demo I taped. Okay. Now, we do need to review some acid and base naming, and we've done this before, but it's been quite some time, and so we're going to review. There are two types of acid. There's binary acids and then polyatomic acids. It'd be helpful if you have your periodic table out because you might need that list of polyatomics on the back. Okay. Binary, if you remember from naming, means two. So in a binary acid, there are only two elements. One of the elements has to be a hydrogen ion, and then you need to have some sort of anion, and that anion is going to be a single element. So something like chlorine or bromine, sulfur, single element. There's not going to be more than that, just two. We name it by putting the prefix hydro out front. Then we write the root of that anion. Then you end it with the suffix -ic, and then write the word acid. So for instance here we have HCl. Well, there's only two elements. There's a hydrogen and there's a chlorine. So we know that that's why we have a binary acid. So we write hydro. Then the root of chlorine is chloro, or chlor. And then we add -ic, acid. So HCl is hydrochloric acid. Polyatomic acids tend to be a little bit more difficult. They still start with a hydrogen, and then you're going to have a polyatomic ion. Oops. An anion. Okay. If that polyatomic's original name ends in -ite, you're going to change the ending to -ous. We call this then nitrous acid. Okay, because this is nitric. Drop the, not nitric, nitrite. Okay, nitrite, drop the ite, add -ous. Okay. If the polyatomic, however, ends in -ate, then we're going to change the ending to -ic. Now this is confusing because binary acids also end in -ic. but binary acids start with hydro. So you have to kind of keep that in mind. Hydro is the only part of a binary, not in a polyatomic. So SO4, this is sulfate. Well, there's that 8 ending, so we drop that and add ic. You can call it sulfic acid, but it's actually called sulfuric acid. For some reason, they add back the UR from sulfur, and so we get sulfuric acid. Bases tend to be a little bit easier. Remember that OH group is going to be at the end, so the only thing you need to do is name the cation, which is a metal ion, and then write the word for OH, which is hydroxide. So our example here, Na is sodium and hydroxide. Now, the only one that is not a hydroxide that you really need to know is NH3. And hopefully you remember that this is ammonia. Okay. So let's try these. Maybe pause the video and then come back. Remember that you have to balance charges. All right, cesium, if you look that up on your periodic table, is CS, has a charge of 1. Then hydroxide is -1. So the formula is just CSOH. Now, we know these last two are acids, but we need to ask ourselves, is it binary or is it polyatomic? Well, this first one has that word hydro. So if it has hydro, that means it's binary. Okay. That means that this iodic part has to have come from just a single atom or element, and iodic sure sounds like iodine to me. So you look, well, hydro, remember acids always start with hydrogen, which have a 1+ charge. I has a 1- charge. When you crisscross, you get just HI. Hi. Okay, hydroiodic acid. Finally, we have phosphoric acid. Notice the absence of that prefix hydro, and so this means we have a polyatomic acid, and we need to think about the ending. So if it came from ic, that meant it was an 8 or a polyatomic, so phosphate. Okay, phosphate is what this came from. Phosphate has a formula PO4 3-. Well, what else goes with an acid? What are we missing? Hydrogens. Okay? You have to have your hydrogens balance out the charge of your anions. So how many hydrogens do we need? We need 3. It's doing the little crisscross thing. So H3PO4. Okay, on your practice, you just have a list of ones that you need to write formulas for, or you need to write names for, and then classify them as either an acid or a base. Thanks. Bye.